Well, hello there. So today I thought we can do this thing. So this is some kind of a force field effect. So you have this sphere which is supposed to be, I don't know, alien ship, Star Trek. And then you have an explosion and poof, the force field as well. So yeah, so we'll be doing this today. Awesome. So I have something prepared already. This amazing ship, which is just a sphere. I want for the explosion to start right over here, let's say. Because it will be more interesting. Because if you start it like right on the top, it won't be as interesting. And if it will be completely on the side, it might be boring as well. But here it will be more challenging and interesting. For that, you can use the new tools, right? Pyro, if I can spell correctly. Pyro configure fireball. This might take a while. Okay. And there it is. Awesome. Except that it's configured for ground explosions. Oh, we have to change the spread angle, I think. Yeah. Awesome. So now if you just press play, okay, there's an explosion and it goes up, but we don't have any gravity in space, right? Best thing is to use actually the normal of where it hits as your gravity. That's why I've added a normal. And then you can do null or maybe gravity. Then right over here, I think in solving, yeah, there's gravity. So you can just use the normal of that point. So the second is point number, we have only one, we'll be using the normal. And 0 for the first component because it's a vector, right? So here we'll change to 1 and 2. So there's our gravity. So now if I press play, it's going this way. And actually I want to go it this way instead of the other way because I want for the flames to start covering the ship. So I'm going to do that. And in setup I have to use open as well so it spreads everywhere, right? Okay. So collision as well. So VDB from polygons and I have to make it quite big, like 1, because my ship is big. It's 100 meters in scale. It's big. So there's a collision. Okay, awesome. And it's boring. It looks bad. So the first thing I'll change is I want for the flames to last longer. So actually for the cooling rate, I'll lower it to like really something low. Then you'll notice the flames will last way longer. So the temperature also stays longer, so it will continuously spread and spread. Okay, way better, right? Already. Yeah, something like this. But it's still boring. I don't like how it hits. There's not much going on. So what I'll do, and what's actually a good practice if you don't know about that already, is actually you can mess with timescale because you will get really cool results. So I will do something like scale it 10 times. Then right over here maybe do 6 and on 20 back to 1. So it will be a big burst and then it will start slowing down. So let's give it a try. Okay, so it looks way better already, right? So it's like big and then it's nicely slowing down, and the more time you spend on, you know, playing with this timescale, the better results you will get. But for me, it's good enough. So now I have this problem that on the top, I like how it spreads, but on the bottom, you can see because my gravity starting to pull everything below this ship in a weird way. I really don't like it. I prefer it to actually like stick to the geometry. Okay, so for that, what I can do and what I will do. So if you jump inside, if you type wrangle, you have gas field wrangle. And here I can do some expression to update the velocity. But what do I do? So since we know where our explosion is happening, we kind of know how big it is. Yeah, I guess this big. So let's drop a sphere, another sphere, and do copy to points. It's probably this big, or maybe 20, maybe even 25. Yeah, I guess something like this. And then I'll just adjust the position to make sure that it's a little bit below, maybe 25 actually. The bigger the better. Okay, I will group those points. Yeah. And probably we'll need more geometry. And I will just blast it. Why not? Okay, so what do we have here? We have points with normals, but except for that, nothing much. But since I started my explosion right over here, we know that it's aligned with x-axis, I would say. You can do this. Say that, hey, the velocity will be the cross product of the normal and the vector 1 in x direction, right? So let's see how the velocity looks like. It's way too small, so I will just multiply by 100. And it's somehow spinning around, and that's great, because the next thing I can do, I do another cross product with the normal and self. And I have a typo here. So basically what I have now are the vectors that are following the surface, right? I can use these vectors as my velocity, except that I will rename it to something else. I'll call it stick. And do just maybe null instead. And call it force. So on this guy, the Gus wrangle, on the inputs, I will use sub node and force. And then I can say int handle is PC open. We'll be opening the first input, which is this binding that the input that I just created. So input 2 stands for 1, and we are sampling position at current position. Then I think we have the radius, and this is a huge ship, so I'll just hard code it to maybe 5, and number of points 10. Then I can do vector v or stick, because it was called stick. PC filter using that handle, and the vector that we used was also called stick. And now we can just do add. Okay, so let's see what we have. Oh, okay, it's definitely working, but it's way too much, right? Okay, this is better. Now except that because of those vectors, they start right over here and they follow along. I literally don't have enough velocity to actually go down, so I will cheat and I will pick another point. Maybe this guy instead. Okay, awesome. So it's behaving way better. So below the ship, it doesn't go down. It actually looks like it sticks to the surface. So that's nice, except that now it looks terrible from the front, right? So I can adjust the velocity for spreading in z-axis as well. So right over here, you know what, I'll make it bigger just in case. And right over here I will do paint, attribute paint, and paint some kind of a mask. And for some reason, usually for paint nodes, when you press shift and right click, you can adjust your brush size, but for this node I cannot do it. Not sure why, so I have to do it manually. And then maybe just attribute blur. Okay, awesome. So now I can say that vector center. I'll take the first input. Actually, second input. I keep saying it's first input. And I need to plug that in, that gravity. And then just say velocity will be current position minus center. And let's see how it looks like. And multiply it as well by 100 just so I can see it. Oh, this is way too much. And it's spreading outside. Awesome. Except that we just want to try to spread it left and right. So I can just say velocity y is 0 and velocity z is 0. Yeah, am I? Nope, x. We need velocities x. Yeah, okay, awesome. You can do it like this if you want, doesn't matter in Vex actually. And then in the end, you can just multiply it by this mask. And now I will say a new vector called explo. I have no idea how to name it seriously. Or maybe spread, you know, this makes much more sense. Spread. And by the way, I'm just assigning it to velocity to preview it easier, so I don't have to create a new vector and then open this up and set it as a vector. It's just way faster. So it's called spread. And then if I go here, maybe let's not use the stick for now. Let's see how the spread looks like. If it's even working or not. I'm not sure. Actually, I think it is. Yeah. But also now, right here on the side, it takes this weird shape. And this is because the vectors here, the velocity that we're adding is basically the same. So it would be cool to actually randomize it somehow. I'm not gonna be doing that, but you can use a noise or a ramp. Okay, so let's add this thickness too. Okay, so this is what I have now, and it looks pretty cool, except for this start, right? When it's basically like a box shape. So you have to adjust those vectors so it's not that only we're adding, because currently we're only adding a lot of force in one axis and the other one. So that's why it's shaped like a box. But then it looks way better. And because we keep adding that velocity because of that sticking thing and because of the collision as well, you have got really cool swirls here, right? Really nice. Okay, because I still have to do that force field, so I would say I'm done. I'm really happy with it. So let's do the force field now. Let's press escape. Enough of the simulation, and we need to cache it as well. Okay, it's finally cached. So it looks something like this. Yeah, it needs a lot of work, especially to have to break this box shape. I still have to do the force field, right? So I'm good with that. Okay, so for the force field, okay, we can grab our gravity. So again, sphere, and I want for it to start somewhere right here. Then I can do Boolean of the force field geometry and this guy, and create the AB sims, and then do the solve the AB sims, delete not selected, and make it to 0. Awesome. Except now if you go to geometry view and primitives, we have 2 primitives. And I want only just one, so I will blast one of them. Let's blast 0. So now if you display your point numbers, they're all messed up. You have like 9 here, 52, 19 here. It's not good, not good. You can do resample. If you just do resample and don't do anything, it will clean your curves. So that's great. But we can also change the the maximum segment length as well. Why not? And I want to use that as my source for the force field. So I will cheat again and I will animate the radius of the sphere, or maybe drop a transform node. It will be easier to animate now. So make it 1 here, maybe something like this, and right over here I want to have it all covered like this, maybe. Explode. And then slow down, right? Yeah, and then it slows down and it will fade in the end. Awesome. I'll subdivide geometry even more because we need plenty of points 2 times. I can do color 0 and color 1 here. Then do attribute transfer. And oh, okay, yeah, awesome. Okay, so on top of that you can do wind up, add some noise, anti-aliased flow noise, plug it into the position, multiply with the current color, and we have to fit it between something because this goes below 0, right? Let's see what we have. Yeah, I guess probably we might need even more geometry. Okay, awesome. On top of that, right over here, we can use that curvy attribute and also transfer the curvy attribute. So instead of using this just position for the noise, you can bind the curvy attribute. Let's do again anti-aliased noise, and let's plug in straight into the color. There you go, you have some kind of, this way it's more shaped like a wave, right? So that's awesome. You know what, let's do anti-aliased flow as well. And also fit it between something like this, probably. Now we can multiply it too. Come on. Oh, come on. Don't be like that. Okay. Yeah, so it has some kind of wave as well. Shapes. And then in the end, I will just bind export this to maybe density. And do pop network. Use this as a source. We will start from 8, maybe 7. And right over here, emission attribute, we can use density. Let's make it 10 times that. And let's not inherit from the color, you know? Let's leave it as it is. Okay, awesome. Except it's not moving, although we have some variation, so that's good. Also, we should animate that since we've been using flow noise. So you can just do multiply constant, the time. Where is time? Like 5. And add it to the flow. Doesn't matter much. I mean, it has to be kind of moving. Yeah. So we need to follow the surface as well, right? First we need the velocity. What's the velocity of that? So if we go back right over here and look what we have. We have only position. We don't have any normals. So what I will do normal. But I will do the normal on top of this guy to make sure it's always correct. Then just do attribute transfer from this guy to this guy. Also, I've added this tangent U attribute. Let's just call it tan for short. So now, if you do vector is the cross product of the normal and this vector tan, Okay, we don't see anything because it's probably super small. So times 100, and there it is. We have proper velocity, right? Awesome. So we have the velocity, and let's see how it looks like. And it doesn't inherit from the velocity because we don't transfer the velocity here. Why can't we transfer the velocity? We have the velocity. Okay, let's do this. Yeah, it's fine. I don't know. And now it will. Awesome. So we have something finally. Oh my god. It took so much time. That's cool. Except that it's not following the surface now. And it's a force field, right? So it has to follow the source field. But it's very easy to fix. And most of you probably know already what I'm gonna do. So again, a VDB from polygons. I'll change it to 1. And where's our sphere? It's right over here. I will call it VDB, just VDB. Here I can do pop wrangle. We can change the input from subdata, or you know, maybe second context geometry, because we can do that and do it right like this. And we need float. I usually call it DT, don't know why. And it's volume sample. This first is the input, second input, you know what I mean. And we need surface, and we're sampling at current position. The surface, what I'm referring to here is this distant VDB field. And then a vector grad is volume gradient. Again, the surface, and we're sampling at current position. And then what I can do is say, hey, just subtract the normalized gradient times this dt, and we should have our magic now happening. Yay! And the points are following the surface now, except that you just saw that, like right over here, you might get this. So what it's doing, this basically, this is a VDB thing. You can sample. You get like the normal of the sample, right? Of the VDB. You get the vector. So like this gradient is like a normal of the volume, and the flow is like a depth, like how far inside or outside the volume you are. But since it's VDB, and if you press W, you know that it has like inner boundaries and outside boundaries. So this is like exterior band voxel and interior band voxel. So we can just do fill interior just to make sure that it's always filled. However, we don't have to do that because the velocities are going like out. So it's more probable that like this, what happened here at some point, where was that? So these points are literally outside of the volume. That's why they didn't sample anything, so they just went whatever they did. So I will just increase that to like 6, and this way it's less likely to happen. Yeah, see? So that's awesome. Except that our velocities are messed up because we're literally adjusting the position. So the pop solver does what it does, and then you just say, hey, adjust the position. But since I'm done with that, I can do this. Get pop object, right? We're getting particles. So once we have these particles, you can just do trail, compute velocity, and use the ID attribute, because pop solver uses ID. Makes sense. Okay, so let's do a little bit of rendering now, because it's getting darker already. Like look how dark it is. Days are so short. I don't want to spend all night doing it, working on it. So let's say I'm happy, and let's try to render something. And we need to adjust it. If I do poly extrude, make it a bit smaller. Yeah, so this will be my ship. I will also do Pico 3 material, create principled shader, call it ship, copy it and call it particles. And quickly assign material. And explosion doesn't need material because we have this spiral look which has a shader and I'll be using that. Okay, so lightning, create some lightning. Let's do skylight. And I don't want that environment map, this and that sky environment map. I want HDRI, and this looks like a sky. Awesome. Do not display that. Render, create, mantra, PBR. Let's force the explosion first, and let's see what we have. And we don't have anything. That's interesting. Do we have anything in alpha? Maybe because we didn't create a camera. Yep, that was it. Okay, it's way too bright. Let's pick some different frame, maybe this one. And if you haven't used this fire look node yet, it's pretty good. However, I will disable the scatter for now and enable the fire. Maybe 15, maybe 5. Probably we have too much smoke. On the simulation that I did here, I lowered the amount of generated smoke. Here we have a lot of density and this is way too much. Okay, maybe something like this. And then on top of that you can add the scatter. Also probably to, yeah, you can get pretty good result with that. Okay, what about the particles? Because explosion is easy. Particles. For the particles we'll be using force field. Okay, let's see what we have if I just render it out like that. Okay, I have to switch to the proper node. Awesome, and it's all green. I don't know, why is it green? Did I add like green color? Maybe. Let's do some different frame. Let's do blue maybe. Okay, awesome. Except the particles are rendered as spheres, right? Basically, during rendering, they're being instantiated as spheres, so usually you have to adjust the p-scale. Now I want to make it a logarithmic float between 0 and 0.05 maybe. Now I can start to adjust it. And yeah, I have not enough particles, of course, and I don't have motion blur, but first of all, I didn't set motion blur here, and second of all, I didn't set the object to have velocity blur, and now it should have velocity blur, and the velocity is probably not enough, right? Let's see if I can multiply it by 10. Yeah, it's way too big. So this was good enough. It's just not enough particles to actually render with velocity blur. Okay, so I quickly added like 10 times more particles. And also when rendering, if you don't know that about already, it might look really bad here, but what's important is actually an alpha channel, right? So the alpha looks way better than the color. If you get the particles too big, the alpha will also start to look really bad, but it still looks good. But if we go too low, there won't be none. Yeah, okay, awesome. So one last thing is the shader for the ship. So let's hide these guys. Let's just leave the ship. And let's go all metallic to 1. Yeah, there's roughness. So name it ship. I want to force object ship. Let's see how it looks like. And okay, we need some color. Let's not use point color at all, and let's make it blue. No, the particles were blue, so greenish, reddish. and darker. It's probably too rough, it's too much. Okay, awesome. And if you add the particles and the explosion as phantom objects, that would be used as reflection. Basically, phantom object is like an object that's there but it's not there. Good naming, phantom. So there you have it, you get it for reflection. Awesome! And that's how you do it, and it's still green. Why the force field is still green. Okay, so that's great. One last thing that you want to probably add is the actual volume light. So if you select the explosion and add the volume light, you get a new light. You can change it to something like this. In 5, in output, I always usually have it as marked as 5. For the explosion, I don't want to use that. As well for the particles. There's the objects. There it is. Okay, awesome. But for the ship, I want to use that. So let's press render again. Is there any difference? Oh yeah, there is difference. Let's make it 5, maybe exposure. Oh yeah, looks pretty cool, right? Yeah, so you can do that for reflections. Same thing for the particles. If you want to make it even glow a little bit, cast some lightning, you can do light, set it to geometry light, but this might get heavy. Then you can do copy to points, sphere, and use that for your light, but it will be instantiating a lot of points as actual geometry. It won't be that heavy, but will be a bit heavier than it is now. Okay, so basically that's it. That's all I did for this, except that, you know, I have 2 different force field waves, and I spent a little bit more time on everything, of course. But as I said, it's like it's so dark already, guys. I don't know why, because it's winter. I really don't like winter. So that's it for now. Hope you guys liked it. If you did, hit that like and subscribe and comment below. Yeah. Okay, thank you for watching and see you guys soon.